So on the ACC, correction, the AACT sheet, you're going to start with 20. Over here, we crossed out this data. We put 0 to 6. We're going to use 50. Hers was amazing.
Yeah, she put it on her Snapchat story.
Oh, fantastic. I did. She was singing something about Disney. She liked my Chemistry Week thing, so I had to like her back because she's amazing. I had last year. Super nice. Nice job, Cody, with number 1. Everybody agree with that?
Yes.
3, 8, 4, 6, 7, 8, 10.
So you had 10. So you had 9 heads. So put the 9 there. So they want you to put the heads back in.
9, and then what do we do now?
Well, you're going to do it twice. So this is your first trial.
Oh, okay.
And then you count again.
1, 2, 3. There's 3.
So you had 1, 2, 3, 4, 5, 6. So then you put 6 there. And you keep going until you get 0.
A 50% chance that it'll turn up heads, and a 50% chance that it will turn up tails. If you assume a penny that lands tails side up result in nuclear decay, then 1 flip of all of the coins should be the equivalent of 1 half-life.
Okay, does everybody agree with 0.25 grams?
No.
What should it be?
0.75.
Yes, it is 0.75 grams.
Oh.
Try your calculator again.
The rate of decay is called half-life. The half-life is defined as the amount of time it takes for half of the atoms in a sample of an element to decay into another element. The half-life is not an exact measurement because it is impossible to tell exactly when each atom decays. So it's what happens on average.
Okay, so in the lab today we have half-life lab and we have half-life Pentium activity. There's more than one way to do a lab. So I've given you 2 different ways to learn the same concept. So what you're going to do today, you're going to do both of these, and then you're going to do the lab write-up on the one you felt you learned the most from. So can I get somebody to read where it says background radioactive elements?
How'd you go from 13 to 22?
No,
Or 22 to 13?
Mr. Steinecker, how many pennies are we throwing at you?
Well, both labs use different amounts. The first one, the American Chemical Association uses 20, I believe. It says 20 pennies there. And the other one I think is using like 100. I would just cut it back to 50 just so it's easier to count out.
The half-life is not an exact measurement because it is.
Am I doing this right?
How many did you start off with? Yes. Okay, so this problem is showing the half-life of 3.5 minutes, the original mine of 48, and it's addressing problem number 3, and there's no reference to that. However, the element is the same. So we're going based on, so we got 0.75 grams as the answer.
You got it. Okay.
Yeah, make up for the
Lab 1, Lab 2. Students are doing both labs and they're going to write up which lab they felt they learned the most from. It's the same concept.
Yes, I did.
Carlos, nice job on the homework. So good. Nice effort there. Okay, so I do not have a answer sheet up here, so I always try to check what somebody else does to make sure it's correct. Cody, he left out part of the formula, T1 half. So if you notice here, there's no T1 half. So I always write the formula first, and then I place the values in. You can see 3 grams, 48 grams, half-life. Half-life of the substance is 3.5 minutes, so it ends up being 14 minutes. Going to be
I don't think that's right.
okay. Looks like you set it up properly. Wait a minute. Take a look at it. Okay, so the first problem we got 14 minutes, which is correct. Does everybody agree with 144 grams?
Sure.
Raise your hand if you agree with that. Okay, it is wrong. It is incorrect.
No, I
Right next to 3.5 equals 14 minutes.
You would make no noise, I would have got bucket.
That's grams. Little G there. Nice job. So that amount will remain.
The amount of time it takes for the half or atom to sample an element to decay into another element. Half-life is not an exact measurement because there's no possible to tell.
One sheet per group, and they're right up based on the one you learned the most from. For this problem, you're going to put 48 times 0.5 caret 21 divided by 3.5 parentheses equals, what'd you get, Koenig?
0.75.
0.75 is correct.
This is hard.
Now there will be a problem like this on the test tomorrow using this formula. So if you're not practicing this now and you're not getting 0.75, that may be a problem for you. Yes, that's it.
Yeah, I'm gonna buy a Lambo with these money.
So on the ACC, correction, the AACT sheet, you're going to start with 20. Over here, we crossed out this data. We put 0 to 6. We're going to use 50. I like this one the most because the data sheet, that is the data table, starts out at 0. This one here, it starts out at 1. That would be incorrect. If you're on a starting line, it always starts at 0. You know, there's not one step there. So on the back side where you see a 1, cross that out and put a 0. So I like this one best. On right here where it says 1, cross it out and put a 0, and then just label it down 1 to 6.